All right, good morning and welcome to our STEM week, day 2. We are so glad that you joined us. And today I want to introduce to you Stacy Sandy. She works with the Golden Spread Electrical Cooperative, and she's going to be talking to you about electrical grids and electrical plants and all of that good stuff. So I'll leave it to you, Stacy.
Okay. Hello. Thank you for having me today. As Kelly mentioned, I'm Stacy Sanning, and I'm going to share some insight into cooperatives, engineering, and artificial intelligence. I am currently employed with Golden Spread Electric Cooperative as the Corporate Strategy Manager. My responsibilities are creating, implementing, and executing our company's corporate strategic plan. This includes our mission, our vision, and strategic initiatives. I have been with Golden Spread nearly 15 years. In the engineering fields, including the electric industry, we use a lot of acronyms. And mechanical engineers are often referred to as MEs, and electrical engineers as Ws, civil engineers are CEs, and the list goes on. So if you hear someone say they're an ME, they're a mechanical engineer. Mechanical engineering is the branch of engineering that applies physics and math to design, analysis, and manufacture of mechanical systems and devices. You can do so many things with a mechanical engineering degree. Core mechanical engineering is built on 3 key areas. They are thermodynamics, material science, and machine design. Thermodynamics is the study of energy and heat and how they change from one form to another. This is crucial for making systems that use energy efficiently. This is my area of mechanical engineering. This is the degree that I chose. Material science is the study of what materials are made of and how they behave. This is really important when engineers need to choose the right material for a part of a machine or a system. And then machine design is about mechanics and dynamics, which is really understanding how objects react to forces and helps engineers predict how machines will work under different conditions. It's super popular now to see combination degrees. So I've listed a few there. You've got aerospace, biomechanical, and robotics. So aerospace engineering is a more specialized area of mechanical engineering focused on building planes and spacecraft. The next one, biomechanical engineering, is considered a subfield of mechanical engineering and biomedical engineering. It really is combining physics, biology, and engineering all together in one package. And the last one, robotics, you might be on a robotics team at your school, but you're designing, building, and using robotics with a focus on creating machines that can think and act independently. So I put together this slide. I think it's a great visual. Engineers, they may invent something new, or they may take something and make it more efficient, make it smaller, less expensive, easier to manufacture. And data storage is an example of this. The evolution of data storage has been quite remarkable, transforming from simple methods to really advanced technologies. Early storage methods include punch cards. You'll see there on that left side, the file system. You would have these cards that would store data through different punched patterns. And in order to run a program, you would have a huge stack of these punched cards, and they had to stay in perfect order to be useful and to run a program or do anything like that. And then in the 1980s and 90s, you have floppy disk and hard drives, and even then into flash drives, all kind of in that era. And I think this is wild. A flash drive can essentially hold the same amount of data as 145,000 floppy disks. So, I mean, just imagine the stack of floppy disk and you have a tiny flash drive, just the transformation that has taken place there. In the 2000s, cloud storage came around and revolutionized data management by allowing data to be stored on huge servers at offsite locations with the ability to be accessed remotely using the internet. So this technology offers great flexibility and scalability. That's probably all you've ever known is cloud storage, but some of us have been through at least the floppy disk and flash drive era. But these advancements have significantly improved how we store, how we access, and how we manage data, paving the way for future generations. I thought this quote was really cool. There are companies that do not yet exist that will build products not yet conceived using materials not yet discovered with methodologies not yet invented. That was a quote from Jim Carroll. He's a futurist. So I often get asked why I chose engineering. Engineering heavily relies on math and science. These were subjects that I was really good in, I felt comfortable in, and I really liked them. So when I was investigating in high school potential career options, engineering made the very top of my list. I also had great high school teachers and college professors that really provided me insight into the idea of engineering as a career and what does that look like. Before my college, both junior and senior years, I participated in summer internships. And I highly recommend that you consider these in whatever field that you choose. It's a fantastic way to get real world experience. And for me, it confirmed my career choice. My very first job out of college was for one of the firms that I had an internship with. So it was a great 3-month interview, really, to learn that I really wanted to do that job. And it is true that engineers are not always the best spellers. So I really had to add this. So here are some key highlights from my career path. Yes, I went to school in the 1900s. I went to school at Amarillo College and Texas Tech, where I eventually earned a mechanical engineering degree. I received several job offers coming out of college, and my first job with utility engineering was in 2001. And I remember my first salary, it was, I want to say like $46,000 a year. For that same work, like right now, would probably be 60,000 or more a year, something like that. But in that role, I was responsible for designing new power plants, working on projects at existing power plants. Those projects were in Texas. They were in New Mexico, California. I even had one in Canada and Florida. I handled many calculation files, system layouts, equipment selections. I was able to collaborate with other engineering co-workers from the electrical group, structural, controls, and the designers associated with all of those. And that experience gave me a huge, deep understanding of the complexities involved with very large scale projects. In 2005, I transitioned to the engineering and construction group with Xcel Energy, and eventually became the site engineer at a power plant called Nichols Station. This role was incredibly rewarding. I was able to apply that design knowledge that I had worked to gain and apply that to daily operations at a power plant. I had to make quick decisions and got to see that power plant in action on a daily basis. In 2001, I married my husband of now 23, almost 24 years. Fun fact, he is also a mechanical engineer. I actually met him at Amarillo College. And we have 2 girls. One is currently at Texas Tech studying kinesiology. And the other one is still in high school, Tascosa High School in Amarillo, Texas. In 2007, I obtained my professional engineering license, which is essential for performing engineering work for the public. It's a requirement. This process involves passing the Fundamentals of Engineering exam, or FE exam. Then you also have to gain experience under a licensed engineer or licensed engineers. And then you must pass the professional engineering exam in your chosen field of study, which for me was mechanical engineering and then that thermodynamics specialty under the ME degree. In 2010, I accepted a position with Golden Spread. As a project manager, I was responsible for the construction of several power plants and other capital projects. And I will share some of those details here in a little bit. I also had another position as the manager of programs. I used my project management skills to develop new programs and services for our members. And currently I oversee the corporate strategy for Golden Spread, which combines really all of those experience. While I no longer perform fluid or thermodynamic calculations, I use my engineering background to solve problems and address strategic decisions for Golden Spread. And in my spare time, I love to serve on boards and committees that support the next generation of STEM. That's super important to me. And a couple of those include, I'm on the Texas Tech Academy of Mechanical Engineers, WTAMU Engineering Advisory Board, Women in Science Endeavors Steering Committee, and the Amarillo College Foundation. So love to serve on all those. The favorite part about my job, I love to problem solve. And I currently get to do that with some great coworkers and for some great cooperatives. So I have a really cool job. And I also appreciate the variety of my work. There are no 2 days that are the same. So I think that's super fun and makes for interesting every day. So I've talked a lot about electric cooperatives and where I've worked, but I want to dive into some of those specifics. What is an electric cooperative for those that may not be familiar? So I have this cutout. I found this article online. It's probably from about the 1930s, which might be the era of some of your great-grandparents. And at that time, rural areas were largely without electricity. So you have cities that were beginning to have electricity and light up, but these rural areas were not getting electricity. The utilities were reluctant to bear the high cost of extending electricity to the rural areas. It's expensive to build out there. That people live far apart. It makes it expensive to build those necessary power lines. This is where electric cooperatives came into play. Many of these cooperatives were established in the 1930s thanks to the Rural Electrification Act. The government provided loan assistance to help rural areas gain access to electricity, primarily to keep these Americans on their farms farming. These cooperatives were often founded by small groups of people who came together in the spirit of cooperation to improve their lives with electricity. There are numerous stories of families investing their entire savings to start their electric cooperative, using loans to build infrastructure, those power lines I talked about, and secure power for their communities. Many of those who lived through this transformative era, or I should say some who lived through this transformative era, are still alive. They're still with us today. And I cannot even imagine how much the world has changed through their lifetime, through their eyes. This is a very simple, high-level illustration that shows rural electric cooperatives receiving, like how the power distribution works. So you've got a rural electric cooperative in the middle, receiving bulk, wholesale, bulk electricity from a power plant through transmission lines. And then on the right side, you can see the distribution electric cooperative providing the energy to their members. This process allows members to have electricity at a reasonable rate. Most of these rural electric cooperatives are still not for profit. So I mentioned I work for Golden Spread nearly 15 years now. So let me dive into who Golden Spread is. So here's a picture of Texas, and the yellow area is where Golden Spread serves. So a large group of distribution electric cooperatives wanted to manage their generation differently, as a group rather than individually, seeking lower cost and the cooperative spirit that I mentioned earlier. These cooperatives came together to form Golden Spread Electric Cooperative. The name Golden Spread was adopted because both the region and the importance of farming, ranching, and related agricultural-based industries. With the exception of a few larger towns, we're still very rural. Our load profile is mainly agricultural, dairy, and oil and gas. Agriculture uses a lot of electricity in the spring and summer with irrigation usage. Oil and gas, as well as dairies, use base load electricity all year long. It's not seasonal. And Golden Spread, as the wholesale provider, must secure electricity, whether in a contract or through an owned resource or a power plant, to meet those energy needs. These are the 16 Golden Spread members. Each of these members are diverse in their energy usage. You might see your area on this map. Golden Spread owns 3 generation sites or power plants, as noted in this graphic. You can see them in the white boxes. I will share a little bit more about these. So before I get into some greater detail on our plants, it's important to understand the term megawatt. So I found this image online, which is super beneficial. So at any one point in time, a watt can provide power to a single LED, just a single tiny LED bulb. And then you can see how that's relative to a toaster, which might be closer to 1,000 watts at any one given time. Well, a megawatt, which you'll hear a little bit about here in just a second, is 1,000,000 watts. So you can think of as a megawatt powering 1,000 homes at any given time. So just a generic home. And a gigawatt is even bigger than that, as you can see in the graphic. So I'll start with Mustang Station. This is an aerial view. This site is located near Denver City, Texas, and the total output is just under 1,000 megawatts. So if you remember, that's a whole lot of homes that this plant can serve. At the top, you can see there's 3 units. You can tell by the stacks. And then on the right side, you've got some more stacks there. This is a close-up of the combined cycle at Mustang Station. We have GE combustion turbines and an ABB steam turbine. This plant was in operation starting in 1999. And this picture also at Mustang Station is a close-up of Unit 6. This is when the unit was under construction. So you can still see some tarps and people standing around getting this unit prepared for commercial operation. I had the honor of being the project manager for this project, and it was operational in 2013. You can see there are a lot of parts and pieces to a plant like this in this close-up. We also own a wind farm, or as we call it at Golden Spread, a wind ranch near Amarillo, Texas. We have 34 Siemens wind turbines for a maximum output of 78 megawatts. I was the project manager for a portion of this project, and it was operational in 2011. Some fun facts that you may or may not know. For a site similar to ours, minimum wind speed to produce power at a site like this is about 6 miles per hour of wind. So that's when you can start producing some electricity. The full output, to get the full output of these wind turbines, it would take a wind speed of about 25 miles per hour, 26 miles per hour. And then when the wind gets above 50 miles an hour, it's probably going to have to shut some of these off because it's no longer safe to operate. So this is a super close up of the hub. This is where the blades are connected to the nacelle at the very top of a wind turbine. The blade sweep diameter is approximately the length of a football field. Another power plant or generation facility that Golden Spread owns is Antelope Station, Antelope Elk Energy Center, located near Abernathy, Texas. It is comprised of Antelope Station, which has 18 Wärtsilä reciprocating engines. They're located inside the red roof that you see on the left side of your screen. And the total output of that site is about 170 megawatts. I was the project manager for this site, and it went commercial in 2011. Now, Elk Station is at the back. You can see the 3 stacks there. One stack goes with each GE combustion turbine. The total site output up there is 600 megawatts. These units were in operation by 2016. This is a photo inside the red roof engine hall. Each engine is 20 cylinders, and you might think that compare that to your car or truck that you might drive to school. Those probably have 4 or 8 cylinders. So these are huge. They're 12,000 horsepower, and they each weigh 300,000 pounds. These engines are commonly used to power cruise ships, and they are unique, and they are able to start and go to full output in less than 5 minutes. And for water conscious area that we live in, they use about 1 gallon of water per engine per day. So they're very environmentally conscious there. This is a close-up of Elk combustion turbines. Those 3 stacks that you saw in the background, these are the combustion turbine associated with those units. These turbines are quick start and can reach full output in less than 15 minutes. And this turbine assembly weighs about 400,000 pounds, so very big. And I want to show you, this is a time lapse of Elk Station under construction. So just a few seconds, but you can just see here, we had a lot of people. We had about 200 on site during the construction. You can see all the cranes. You can see things starting to take shape. Oh, there goes the stack. You can see that growing. It's 130 feet tall. You can also see all the seasons that we had to work around during construction, including snow and rain and everything in between. But you can see here the final product of Elk Station. So it's kind of a cool video. So you might be asking yourself, okay, what does engineering and cooperatives have to do with artificial intelligence or AI? So you should probably start with, what is AI really? Well, I used AI and requested a simple definition, and this is what I received. Artificial intelligence is a field of computer science that focuses on creating systems capable of performing tasks that typically require human intelligence. These tasks include things like understanding natural language, recognizing patterns, solving problems, and making decisions. I really like this summary piece of it. Essentially, AI enables machines to learn from experience, adapt to new inputs, and perform human-like activities. So the AI computing process hosts vast amounts of data for cloud service providers like Google, Amazon, Microsoft. The AI work is performed and stored in data centers, which are specialized facilities that house computer systems, servers, networking equipment. These data centers are located all over, and they are wanting to be in Texas. A lot of these are wanting to be in Texas, where electricity is less expensive and the land is vast. Data centers are very energy intensive, with single data centers using more electricity than some small countries. So they're huge. Perhaps you've used Alexa, ChatGPT, or Copilot Those are all examples of AI. Data centers are everywhere. They are coming in hot, they are coming in fast, and as I mentioned, they use a lot of electricity. This is a small sampling of titles when I just did a quick article search on the internet. So easy to find information related to AI. So here is a great example of a Google search versus an AI search. The AI search takes 5 times the amount of energy or electricity to perform a search. For Google, the search uses keywords and finds similar matches, where AI takes that search and puts phrases together in a more executable format. Electrically serving the AI data centers comes with challenges and opportunities, risk and rewards. You can see in this photo the magnitude of data centers versus traditional electric loads such as homes, irrigation, dairies, some of those things. A single data center might be the same amount as a traditional load. So you can just see it's really tilting. It's making a huge impact from a load perspective. So you might be asking yourself, is AI good? Is AI safe? And the answer is yes. AI offers a lot of things from an electrical cooperative perspective. They're a quality energy consumer. They use a lot of electricity all of the time. So that's a good load. There's also smart grid management, enhancing electricity distribution through enhancing electricity distribution. There's also demand response. So this is when, they're able to help, AI is able to help predict energy demand patterns and adjust the supply accordingly. There's also renewable energy integration. So it can help forecast generation and renewable sources by balancing the supply and demand in real time. There's also equipment monitoring, using AI to predict failures in critical infrastructure like transformers, turbines, some of those equipment that I talked about earlier. Oh. There's also asset management, extending the lifespan of equipment, optimizing maintenance schedules. Some of those things help predict some of those things. And there's also grid infrastructure monitoring. So by detecting anomalies and preventing faults, just and to enhance reliability. These are just a brief list. There's so much more in development in all of these areas, and how to and the big thing for us is how to physically provide electricity to these incredibly large loads while still meeting our traditional member needs. So we really want to balance that in all that we do. So just imagine for a second if in the rural areas of those 1930s and 40s, if they didn't cooperate and if they didn't work together to solve a big problem of that lack of electricity, where would we be today? And then also think about how the electric grid may be radically different 25 years from now or more. But it doesn't affect how we as electric cooperatives serve our members, but it may affect the tools in which we do it with. And I really love this quote from Wes, I guess Fessler is how you say his last name, but it's cooperation is the redeeming ability of man to be better than himself. So it's the idea of coming together and working together and to be better for mankind altogether. So I thank you for your time today. Appreciate you allowing me to speak to you about cooperatives, engineering, and AI. Oh my. I will now answer any questions that you might have.
I have one question. In your presentation, you had the windmill energy. What other types of energy do y'all use to produce your electricity for your co-op?
Great question. So we also use natural gas. So Mustang Station, okay, I'm gonna put my camera too. Mustang Station and Antelope Station and Elk Station, they all use natural gas
Okay.
to supply those plants and produce electricity.
Do y'all like plan on expanding into the renewable, or is that just, I
So
know
we
that
do
those
have
questions.
the wind turbines, so that is
Mhm.
considered a renewable wind resource. And we have a couple of contracts on some additional renewable resources, but so that's what we own right now.
All right. And then you had mentioned robotics earlier. We have quite a few districts that have robotics teams, and we actually have a CE and collaborative robotics team. What do you what advice would you give to those students in those robotics program who may want to go into this field?
Oh, I think robotics is really great. And I think that's a lot of things are becoming automated and being used from a robotics perspective. And I think having that experience in your high school and is so great. And college will just build on that. But I think robotics is awesome, and I think it's a great field to consider.
And then you also mentioned internships. And how would someone go about, trying to earn an internship in college?
Internships are so important. I encourage every college student to at least do one, if not two internships, and maybe even in a little bit different fields of study. So you can kind of determine if it's what you like. So you get 3 months at a business, a corporation, and you get to do what an engineer does all summer long and determine if that's indeed what you want to do. And so the way to get one is through your university. I'm sure there's similar to maybe your high school where you have a college and career type center. A lot of universities have that too. And they'll have different companies that post different job opportunities, but they come early. Don't wait until April or May to try to find one of those. You're going to want to do that in the fall semester to try to secure something for the summer.
And then just the size of those plants, I mean, it's just enormous. What types of jobs, if someone was interested in going to this field, what types of jobs? I mean, it's got to be enormous. I mean, y'all have to have huge employment. What types of jobs are available?
Well, so, there's everything from, let's start with the construction of the plant. So even just with the construction, you have engineers that are designing what is going in the plant. And then you also have craftsmen, trades who, electricians and journeymen and those kind of people who are installing all the equipment and doing the hands-on services. And then you have, once it's built, the power plant is built, you have operations teams that are managing that plant and keeping it highly maintained and working properly. So you have maintenance folks at the site and operations folks doing this on the daily basis. And then also we talked about distribution co-ops. Well, within the distribution co-op, you have linemen, you have electricians, you have different staff that are keeping the lights on, if you will, for people that they serve. So vast amount of people from start to finish. And then at Golden Spread, we're helping support that wholesale power too, helping support the generation sites and the members and everything in between.
And then with the data centers, I mean, that's a huge tax on electricity. Is there enough electricity to go around?
That's a great question. Um, I think you'll find that new power plants are going to be required to serve the vast amounts of data centers that are coming. Um, It's still years out, so it's something that can still develop over time, but you're right. It's going to require some infrastructure build.
All right, that's all we have for questions. Do you have anything else you want to add, or?
I don't. Thanks for having me.
Thank you so much. We appreciate you. This was a wonderful session. We great information, and we really appreciate you. All
Thank
right,
you. Have a great day.
you too. Bye-bye.